Good morning, everybody. Welcome to the third day of our Rutronik Connects webinar series. In this week, we are focusing on Wi-Fi technology. My name is Kerstin Nasser. I'm Corporate Product Manager for Wireless Technologies at Rutronik. And with me today are our partners Intel and KYOCERA AVX. From Intel, we have our experts Albertano Caruso and Frank Merten. And from KYOCERA AVX, we have Mr. Jens Kappenbusch with us today. Intel will introduce us to their M.2 Wi-Fi plus Bluetooth combo solutions. And KYOCERA AVX will introduce the perfect fitting antenna solutions for these combo cards. Before we start, I'd like to give you some general information on the webinar first. So the duration of this webinar will be around about 1 hour. We have a question and answer session included at the end of the webinar. So if you have any questions, please use the chat window on the right side. And of course, if you have any questions later on, you can always contact us as well. The presentation slides and the recording itself will be available later on also. So that's all from my side at this moment. I would hand over to our experts from Intel now. So please feel free to start.
Good. Thank you, Kerstin, for the introduction, and welcome everyone. Thanks for this invitation, Kerstin. We're working for a while already with Rutronik, very trustful relationship. And we're happy to talk about Intel's Wi-Fi products today here, especially Wi-Fi 7. And with this, I would like to hand over to Albertano Caruso, our FAE, who will give you more information about our product lineup. Albertano, over to you.
Thank you, Frank. So good morning and welcome everybody, also from my side. Thank you for joining this training session of today. We will explore the latest Wi-Fi development and see how Intel products are at the front end of this technology. My name is Albertano Caruso, and I'm working at Intel as field application engineer. So let's take a quick look at the agenda we will be covering today. So we will start having a look at the Wi-Fi standards, which are the foundation of all Wi-Fi products in our portfolio. Next, we will delve into the key feature of the latest Wi-Fi 7 standard, which was launched at the beginning of this year. We will then explore the Intel Wi-Fi roadmap, covering both NEXT and CCG roadmaps. We will highlight the Intel value proposition in the Wi-Fi space and provide an overview of the latest Gale Peak 2, which is Wi-Fi 7 module. Then we will have a section dedicated how to design and test with our Wi-Fi modules. We'll touch also on the topic of Wi-Fi certification, and then we can open the floor to the questions. So let's begin with an overview of Wi-Fi standards. So understanding the evolution of Wi-Fi standards help us to appreciate how it has continuously met the increasing demands of faster data speeds, more reliable connection, greater network capacity. And as you can see here, each iteration of Wi-Fi brings advancement that enhance user experience, increase throughput, reduce interference, and also bolster security features. Intel has been at the front end of Wi-Fi technology, leading innovation and also participating in the industry alliances. Intel also pioneers new features that improve connectivity and performance of Wi-Fi. Wi-Fi technology has been a cornerstone of wireless networking for over the last 2 decades. The first standard has been released in 1997, and all Wi-Fi standards are managed by the IEEE and all are backwards compatible. As you can see here, key advancements across Wi-Fi standards generation include enhancement in radio bands, channel width, number of streams, speed, and also signal modulation techniques. In the last 4 iterations, we moved, for example, from the 600 megabit per second of Wi-Fi 4 to the 46 gigabit per second of Wi-Fi 7. Now, which are the major enhancements that Wi-Fi 7, the latest standard, brings to the table? Wi-Fi 7 is also known as extremely high throughput standard. It introduces several key enhancements designed to improve in a significant way network efficiency, capacity, latency, and also speed. And as we now delve into these features in the next slides, we will see how they improve performance, efficiency, and reliability of the Wi-Fi networks. So let's start with the channel bandwidth. Wi-Fi 7 supports channel bandwidth up to 312 megahertz, so doubling the maximum bandwidth available in Wi-Fi 6, which is 160 megahertz. This wider bandwidth allows for more data to be transmitted at the same time, and this improves in a quite significant way the network throughput. It also allows to accommodate more data-intensive applications, such as, for example, virtual reality or ultra-high definition video streaming. Next, Wi-Fi 7 supports a faster modulation rate. We are moving from the 1024 QAM of Wi-Fi 6 to 4000 QAM of Wi-Fi 7. So that means Wi-Fi 7 can encode more bits per symbol, which translate to a higher data rates. Increased single peak data rates can reach up to 5.66 gigabit per second per link. That means about 2.4 times faster than a Wi-Fi 6 connection. Wi-Fi 7 introduces also a new feature called multi-resources unit and puncturing. Puncturing addresses the issue of interference in incumbent RF spectrum usage that makes a complete channel unavailable. And as you can see here, illustrating this example, without puncturing, channel 31 becomes completely unavailable due to the 40 megahertz incumbent RF spectrum usage. But with adoption of the puncturing feature, the remaining part of channel 31 is kept available while avoiding parts of the spectrum that are experiencing interference. So the benefit of this feature of puncturing feature is to enable a more effective use of the spectrum, maintaining high performance even in congested environments. Last is the multi-link operation feature in Wi-Fi 7. This feature allows a device to operate across multiple frequency bands or channels simultaneously. That means a Wi-Fi 7 device can transmit and receive data on more than one frequency band at the same time. And this capability allows for more flexible and efficient use of the available spectrum. The primary advantage of using multiple bands in a simultaneously way is the significant increase of the data throughput. And these results, of course, in faster data rates, which are crucial for bandwidth-intensive applications. Additionally, a multi-link operation enhances the reliability of the network connection, providing alternative paths for data transmission. And this kind of redundancy helps in avoiding interference and mitigating the effect of poor channel condition in any single band. Application that requires low latency, such as, for example, gaming or video streaming, see a substantial benefit from this feature. Now, before we move to the Intel Wi-Fi products roadmap, let me outline 3 key aspects that are essential for a comprehensive understanding of our roadmap. The first aspect is related with the use condition of Wi-Fi modules. We offering modules designed for PC client, embedded, and industrial use conditions, and each of these is tailored to meet specific operational demands. The modules for PC client use condition ensure 5 years of reliability with 30% active usage, and they operate within a temperature range from 0 to 50 Celsius degrees, and making them ideal for general consumer electronics. Then we have the modules for embedded use condition, which are built for more demanding environments, providing 5 years of reliability within 80% of active time. They can operate in a broader temperature range from 0 to 70 Celsius degrees and are suitable for embedded system in various industrial applications. The modules for industrial use condition are engineered for the toughest environments. They offer extended reliability of 10 years with 100% of active time. They are capable of operating in extreme temperature ranging from -40 to 85 Celsius degrees, so ensuring robust performance in critical industrial settings. Some important note is, regardless the use condition, RF performance and features of the Wi-Fi modules remain consistent, and this kind of uniformity ensures that no changes are required in the platform hardware design across different applications. Additionally, a single driver package supports all conditions, simplifying the integration process. So we can leverage the same module certification for all conditions, enhancing efficiency and also reducing time to market. Second aspect is related to the 2 distinct types of Wi-Fi modules that we offer. We have a discrete and we have an integrated solution. The discrete solution encompasses both the RF part and the MAC digital part within the Wi-Fi module itself. This module connects to the host system through a standard PCI interface, so ensuring broad compatibility and easy integration. On the other hand, we have the integrated solution, which takes a different approach and is doing a relocation of the MAC block component from the radio chip directly to the Intel SoC chip. So the signal processing, the analog and the RF function are maintained within what we call the companion RF module. What is important to note is this kind of solution is an Intel proprietary interface known as CNVI and should be connected to an Intel host. The last aspect is related to the 2 different kinds of form factor that we offer. On the left side, you can see the M.2 2230 module. This is a module that utilizes a standard key socket, which is commonly used for attaching smaller modules to a motherboard, allowing for easy upgrade and maintenance. And on the right side, we have the M.2 1216, which is soldered directly onto the motherboard. So this kind of method can reduce physical space required, but on the other side, limiting modularity of the platform. So now that we have clarified these 3 aspects, let's begin with the CCG Wi-Fi roadmap. CCG Wi-Fi solution tailored for consumer application within PC client environments. We have 5 years of product availability and 7 years of product support. Let's focus on discrete Wi-Fi modules. We have launched the Wi-Fi 7 module in 2 variants, the B200 and the B202, with different from which have different bandwidth support. Then we offer the module Typhoon Peak 2 and Cyclone Peak 2, which are Wi-Fi 6 and 6E modules. We have, from now transitioning to integrated Wi-Fi modules, we have Filmer Peak 2, which will be launching Q4 of this year, and it is compatible with Lunar Lake and Arrow Lake platforms. We have also Wi-Fi 6 integrated modules compatible with Alder Lake, Raptor Lake, and Meteor Lake platforms. We still have in the platform also Wi-Fi 6 module with our Harrison Peak and Jason Peak module. And then last but not least, we also still have in the platform our Wi-Fi 5 module, integrated, sorry. So now transitioning from the CCG to the next wireless roadmap, the next modules provide longer life. That means 7 years product availability and 7 years product support. In the portfolio, we have added embedded and industrial modules to address IoT design in. We have the Thunder Peak 2 as integrated Wi-Fi module supporting PC client use condition, which is taken from the CCG. In the space of discrete modules, we have the Gale Peak 2 in Wi-Fi 7 space, which is planned to be launched in Q4 of this year. Then we have the Typhoon Peak 2, which support both embedded industrial use condition, which is available. And we still have the Wi-Fi 5 module, the Thunder Peak 2, for embedded industrial use condition as well. Now, some value proposition of our Wi-Fi modules. As we have seen, they support a diverse range of operating system, Linux and Windows 10. A standout feature of our modules is the integration of Intel vPro technology. vPro is an Intel technology that enhances security through hardware shields and facilitates remote management capabilities. Intel Wi-Fi modules are designed to operate under commercial, embedded, and industrial use condition. And this kind of versatility ensures that our modules are suitable for a wide range of application, from office environments to the more demanding industrial settings. To ensure reliability and compatibility, our Wi-Fi modules have been pre-validated across an extensive set of Intel platforms. And we have already mentioned, we offer a long product life cycle for the all use condition parts, ensuring that our modules will support customer needs long into the future. Last but not least, our commitment to global standard is also demonstrated by the certification of the Wi-Fi modules in over 120 countries. Gale Peak 2 represents the cutting edge of the latest Wi-Fi 7 technology. Here you can see summarized the key characteristic of the Gale Peak 2 that we have already discussed in the previous slide. The module is available in the 2 form factor, the 2030 and 1216, and both with and without vPro support. It has been validated on the latest Intel platforms, including Meteor Lake and Raptor Lake refresh. It supports operating system Windows, Linux, and Chrome, and it also supports the Bluetooth version 5.4 with all related features. So now, as you integrated the Wi-Fi 7 into an embedded industrial design, it's essential to keep the following key points in mind. It's important to note that the Gale Peak 2 maintains the same height and shield board dimension of its predecessor, the X210. The Gale Peak for embedded industrial pinout is the same of a KEE scheme. So this is crucial for designer to note. That means compatibility is exclusive to the M.2 KE connector. Regarding the connectivity, the antenna design needs special attention, because this required support of the 3 bands, 2.4, 5, and 6, which are essential for leveraging the full capacity of Wi-Fi 7. On the software side, it's imperative to incorporate a new version driver starting from 23, update the BIOS, which support the new feature of Wi-Fi 7. On operating system support, we have Windows OS 11, SV3. We have also Windows OS 11 LTSC. And for Linux, Ubuntu will support Wi-Fi 7 starting from kernel version 6.2. We also provide a operating and maintenance tool for the 3 different phases of development following the board layout design. We have the diagnostic and regularity test utility, which is used for regularity test and radio performance test. We have an interface test utility that performs traffic testing between integrated connectivity interface and Wi-Fi module. We have an antenna tool, which is used for manufacturing development phase and perform RSSI test. We also have a noise diagnostic tool, which detects platform noise. So it is a quite exhaustive test utility that are together with our Wi-Fi modules. How to get started with Intel wireless design. So here, the wireless connectivity message of the month is the essential guide to the latest release version of our tools. It includes reference to collaterals such as driver version, hardware design guidelines, debug checklist, and much more. Design checklist highlights design consideration that should be reviewed prior to manufacturing a system board. Additionally, for Wi-Fi 7, we provide specific design guidance for ensuring optimal integration. Now, regularity certification for Intel product is mandatory, and every country has its own set of requirements. There are many kinds of requirements, such as RF, EMC, and also product safety testing. All our Intel wireless modules are approved in over 120 countries. Here you can find some documents you should be aware of. We have a document that lists all approved countries. We have a document that provides detailed information and guidance on the wireless certification process, testing tools, and so on. And also we provide a wireless regulatory website that hosts different documents covering a broad range of topics, including marking, declaration of conformity, type of examination certification, and all these kind of documents are available to be downloaded. So this is how it looks like, this wireless regulatory website that I mentioned. Here you can see the AX210 as an example, and you can see the regulatory marking document on the right side. And this kind of image provides a reference of regulatory marking for each country and indicate whether these markings are required to appear on either the product itself or in its packaging. Okay, so this is all from my side. If you have any question, please let me know. Thank you.
Thank you, Gaetano, for the very nice introduction. And I will just go ahead and do my part on the antennas. We just heard from Albertano from Intel some guidelines on how to design in the wireless modules, and of course after that the antenna part is still open. That's what I'm covering today in this short webinar together with Rutronik, also our long-term partner, since basically AVX started with antenna business. We always worked together with Rutronik, so thank you again from my side as well to participate in this webinar session. My name is Jens Kattenbusch and I'm the Regional Technical Sales Manager for the RF components at KYOCERA AVX. I'm located in Germany. I'm covering the DACH region, Central Europe, and also Eastern Europe. So in case of any questions, any design support you will need, you can either contact your local Rutronik contacts or, of course, directly me. Ethertronics or AVX, KYOCERA AVX acquired Ethertronics a couple of years ago. Originally, it was a big part, a big supplier in custom antenna designs. We still do a lot of custom parts, but since the acquisition, we focus much more on standard components, and we are still very, very strong in the design and in our antenna design ourselves. We also do our own measurement chambers or measurement systems that we provide, and that's why we are very focused on these patterns and on the general design in and helping our customers to have the perfect antenna for each application. We have active and passive antenna systems, measuring systems, and generally high quality of products. Later on I will show our production sites, which are not only in China, for example, but also other sites. And we always try to integrate the whole antenna system in complex environments, also, of course, together with our partners for the modules and the chips. In terms of application, yep.
Sorry for the interruption, but I just received the information that your presentation can't be seen. Probably you just restart the presentation.
Is it better now? Can you see it?
We would need to wait for around about half a minute because we have some delay in it, but you can just continue to with your presentation. I will let you know if we need to restart again. Sorry.
Yeah, no worries. Thanks. So our key applications are from automotive to industrial M2M, IoT, but we are also quite strong in embedded gateways, routers, mobile communications like cell phones, wearables, metering, and 5G as well. We also have dedicated medical antennas, also covering some FDA classes if that's required. So we have a very, very broad portfolio of standard and custom parts. Here you can see our, I hope you can see our different sites worldwide. So we have some design and manufacturing plants in Asia, design in Korea, Taiwan, and China, production in Vietnam. We have 2 facilities in Vietnam, one in Korea, and one in China. And our design services mainly come from France and San Diego. So for Europe, the closest location is in France, close to Nice. And that's where we also have most of our measurement chambers and most of our people located. So that's really perfect for European customers. In terms of products that we offer, and especially for this webinar, we picked a few applications we want to dive into a little bit more and show some products that we see mainly used in these applications, which are industrial gateways, wearables, automotive, and smart homes, or smart buildings in general. We offer all kinds of different variations for antennas, starting from the standard SMD types, metal stamped, but also adhesive antennas, as you can see here, or standard stubby antennas that you can just mount via SMA connector. As mentioned, we do also custom designs. So on the bottom left side, you can see, for example, some LDS custom design, which we made for a wearable customer. So we saw already from Intel that the design is quite important, and we also saw that the Wi-Fi 7 range is increased compared to previous Wi-Fi versions, covering also the 6 gigahertz band up to 7 gigahertz roughly, having more channels, more bandwidth in general. So the question is basically what type of antenna is required, how to pick the right antenna. And the first question, of course, always is, besides what type of antenna, if it's a stubby mount, connector mount, or adhesive mount, or chip antenna maybe, what are the bands that must be covered? And I think here, especially having the puncturing as a new feature, we can really focus on tuning our antennas to specific frequency ranges, specific bands, and so on. So that's always something that needs to be considered in advance to pick the antenna and to pick the best antenna. Second question is what kind of connector is required. There are many different versions. Standard ones are RPSMA or SMA, but some customers maybe also need a FACRA connector or others. Usually we can promote different ones. For the onboard part or on module part directly, we also use the standard MHF4L or MHF4 connectors, which are the smaller UFL part connectors. Another thing is the challenges in the antenna setup. So how to integrate the antenna, how to position the antenna, and of course also what are the surroundings. Sometimes we have a lot of customers having a metal cage basically where they want to get some signal out, and not always the easiest solution, like the adhesive PCB antenna, for example, is the best solution because it doesn't provide signal outside of this metal cage. So there needs to be another solution, and that's where we have very strong support in Europe, but also in the US and Asia on how to integrate the antenna in each application individually. Starting with some products now, I will just show that we also offer chip antennas, and we generally cover most common technologies from cellular to ultra wideband, BLE Wi-Fi, also now DECT ML+ again, in SMT mount variations. So we have many different form factors that we can offer. And one of our biggest benefits is that we can offer always some antennas that are suitable for a customer's application. Often we see customers doing their designs and they see, okay, the antenna is quite small. Let's just put it in some corner and it will work, but that's not always the case. And with our broad portfolio, we can always offer an antenna that fits different positions with different variations of ground clearance that's required to have the best antenna performance. And so you can really choose the best antenna based on the requirements or based on the application and on the position of the product. So as you can see here, we have some of the smallest sizes in the market. In terms of the chip antennas, the smallest ones are just 1 millimeter by 0.55 millimeters. So it's really small. The standard sizes for capacitors already, but now we also have some antennas that we can provide with this form factor, also having a benefit, of course, of being lightweight and even lighter than previous versions. In terms of applications, we mainly see it, of course, in the wearables, telematics, IoT, industrial, and asset tracking, but also, for example, tire pressure monitoring systems in automotive. We usually always have automotive versions available of our SMT parts, which are not only used in automotive, but because they have a broader temperature range up to 150 degrees, and vibration and mechanical shock resistance. They're also used in railway applications, for example, in drones, in heavy industrial machines that have high vibrations. So you can be sure the antenna will not move or will not fall off, and the RF performance is always the same. For some specific environments, especially when you have a lot of metal around, we typically see it in smart home applications when you have some kind of panel in the to control the doors, to control the smart home. You have a display, you have like a small metal cage, and in these kinds of applications, we see the metal stamped antennas as quite advanced because they're not very sensitive to the different environments compared to other types of antennas like chip antennas or trace antennas. But I will just go ahead and focus on the nice FPC PCB antennas with cable, because they typically directly fit on the Intel modules. We just saw some UFL connectors or the smaller ones, MHF4 connectors on the different modules. And of course, that's always something to consider when choosing the module or when choosing the antenna to the module, what type of connector is required. Sometimes it's the MHF1 or UFL connector, but the latest modules like the PE200 just supports the smaller one, the smaller form factor. And lately we also added to our portfolio the locked connectors. So you just have a small sliding mechanism that you can close quite quickly. You can even release it, so you have a very strong connection, and you can be sure that the connector doesn't fall off of your antenna. In terms of different types of antennas, we focused on the standard frequency ranges, having different types like the centered cable or the cable to the side. We also have this tunable antennas covering also Wi-Fi 7. The trick here is that if you have a big housing or a thick housing, the frequency will shift a little bit. So you might have to adjust the frequency shift to center the frequency according to the new housing. And this can be done by adding some components on this PCB or removing some traces here. We can do that in our factory already in advance if that is required. And this antenna is also used for medical applications, for example. Another highlight is that we have this metal antenna, so you can just stick it to metal, which is usually not the case. Typically, the other antennas are only to be used on some plastic carriers and no metal. I mean, metal is usually the death of RF signal, but here this antenna is very, very strong in the environment. And it's quite small, actually. It doesn't look like it, but I think it's around 30 millimeters in size. So here also we see a lot, of course, in the IoT industrial applications, also smart home, some gateways, robotics, and drones, as these are quite typical markets for these types of applications, usually not super high quantities, but still worth it. And you can just add the antennas very easily to the module. Now, this is a very new series on the left side, which is called our W family. So we have four brand new antennas that we just released this year, which cover the 3-band Wi-Fi, so Wi-Fi 6E and 7, so 2.4, 5, and 6 gigahertz bands, which is the W7 and the W4. We also have our W5 and W6 series, which cover either only the upper 2 bands or just the upper band, the latest one. The benefit of that is that you can just have two separate networks, one 2.4 gigahertz network and one, for example, 5 gigahertz network, or 1 5 and 1 6 gigahertz network, and so the bands don't cross, and you might avoid some disturbance, some noise in the 2.4 gigahertz band in general. In terms of form factors, the parts are also quite small, I would say. So here we have around 15 millimeters in size, and this is around 35, which is still 3.5 centimeters, so it's really small. Our old families are still available. The latest parts, of course, are much better in performance, or a bit better in performance usually. The thing is, that's not always better for certification. So we still have our old products with a little bit lower gain for the tree band. So you can be sure that you will pass the certification. Because as Albertano just said, the certification is a critical point, and you have to check each module and the requirements for each frequency band. What are the required gains? What are the required values to certify the antenna right away? Typically, when it's measured, the better antennas are better, but it needs to be measured in the device, in the application, to see if the gain is not exceeded or if it's still within the gain. So that's why we still have both families available. A third family is our WX series, and as you can see on the right side here in the orientation, in the radiation pattern, we have different versions, the WAP, WBP, and WCP, and each have a different orientation for the radiation pattern. So it depends on where you mount the antenna, where you have to go. If you have to go on the x-axis, on the z-axis, on the y-axis, and which area you have to cover. In this case, we can offer these solutions if it's required to have just a specific direction to be covered. Last but not least, we also have our external antennas. Of course, that's quite interesting for many applications, especially in the environment field, in the industrial field. Usually what we do is to split our portfolio for outdoor antennas and indoor antennas. Indoor antennas are not IP certified, but our outdoor antennas are typically certified according to IP67 or at least IPX7. So we have the water resistance and typically also the dust resistance. So as you can see here in the center, that's one of our IP67 rated antennas. It's an external RPSMA connector mount antenna. The reason why we use typically RPSMA is because it's just a little bit more resistant for attaching and detaching the antenna a couple of times. And that's basically the reason why both standards have developed SMA and RPSMA. The difference is just that the pin is on the other side, so it's not that critical to break for the RPSMA. We also have this very nice UFL connector mount external antenna that you can just use as it is. You don't need an adapter cable. You can just put it through some mounting hole, and there's some kind of nose that attaches the antenna and fixes the antenna. So that's very, very easy to use. But of course, we also offer the cables. Since we came from mostly custom designs, we just start also selling the cables as a standard component. And they will be available at Rutronik also soon. So we're just preparing some packages, just ordering a bunch of different sizes, different adapter parts, RPSMA, SMA to MHF4, MHF1, and all different other kinds of connectors. So we just have them in stock. Typically also we have the other antennas in stock. So you can just order some samples from Rutronik or from ourselves, and you can just start with your design. And this antenna is just a random standard antenna, and that you can just mount very, very easily to your SMA connector. And we also have the swivel antennas, so you can just hinge the connectors and turn them around to whatever direction you need. That might be important if you want to cover different areas. So you have one antenna straight and one a little bit to the side. So you can just cover the horizontal and vertical polarization. Typically also these antennas are for Wi-Fi 7. Some of these older ones we still have are for Wi-Fi 5 and 6. So that needs to be checked, of course, as I mentioned in advance. What are the frequencies and the frequency bands required? Is it only the Wi-Fi 7 gigahertz range up to 6 gigahertz, or is 5 gigahertz also okay? And we just heard from Intel the benefits of Wi-Fi 7, and I think that's also a big part to have reliable antennas together with a reliable system. And that's why we do a lot of services to support our customers in terms of design. So each application has the best antenna to fit, and the most reliable antenna and the most efficient antenna. If you have a very, very efficient module, but the antenna is crap, then you can just you just lose all the efficiency that comes with the latest standards. So that's why we highly recommend to use the services and to just have a look at the application, at the design, if there's any room for improvement. Of course, always for the external antennas, there's not much room for improvement. And as I said before, if you have the best antenna, you might not pass the certification. So there's always some drawbacks you have to consider when choosing the antenna. But if you're done with your basic design, we can have a layout review. We can do some simulations or make an offer for some fully custom designs and some more measurements. So if you have a standard part, you can just send in your application and we can measure it. If you don't have a standard part already, we can do the prototyping as a custom antenna. Usually the easiest custom part is just a standard FPC product that we can adapt to different frequencies, to different form factors. So we can just perfectly integrate our antenna in your application, no matter if it's a more complex design or more easier design. Also different sizes, of course, we can adapt with our standard products and do some very easy prototyping in our facilities. In France, for example, we have multiple 3D printers to create housings. So you can just send a 3D file, we can create a housing, and we can match our antenna exactly in this housing. And if you just send a standard part, we will just do some measurements. If you can provide some of your prototypes or some applications of yours, we can do the measurements, the tuning and optimization, active and passive testing. Also then validation and factory sampling. Even have a second round to test all the parts again. Have the final test report of custom parts. And just say, okay, you're good to go. You can go to mass production, or we can go to mass production with our standard, with our custom parts. And then you have the best antenna in terms of performance that'll just be good enough to pass certification, and perfect and the maximum performance to reach in each application, as good as possible. And these are some of our test services. So as I said, in France, we have the next chamber, including our automotive chamber, where we can also test very big devices, not only cars. We also do fridges. We also do heating pumps. We can also do HVAC. We can do basically everything that fits on this big plate. I think it's 7 by 7 meters. So you have a lot of space. If you have a bigger product, you need to measure. For smaller products, we also have our smaller chambers that we can just integrate or just measure small applications. We also do our own measurement chambers ourselves partly. So if you have a very specific request for specific measurements, we can also try and create some systems for that. Other than that, what we do offer as well is Wi-Fi throughput measurements, for example. And besides the standard comparisons, either if it's a competitor compared to our antenna, or if it's a previous design compared to our optimized design in terms of return loss, isolation, efficiency, and gain, we can do MIMO measurements. So we can combine both antennas in case you have a 2x2 MIMO or even higher. We can create some 3D patterns on both antennas combined. So you do not measure each single individual antenna, but you have both antennas optimized, and both antennas are shown in the radiation pattern, so you can really see what is the combined radiation pattern. Our frequency range also covering, of course, the Wi-Fi range from 400 megahertz to 68 gigahertz. So even partially, we work in the cellular 5G environment. So to summarize it and keep some space for questions afterwards, we are a globally known manufacturer of antennas, but also other components. We have a very broad and very long history with antennas, a very good knowledge and extensive experience in all kinds of applications. As I said, we came from the custom products, and now we can share our experience from these custom products and highly specific designs to optimize our standard components in each single application. We can do standard components, but if it's really required, we also do full custom designs. So we have different levels of customization. Either it's just changing a cable length, for example, or changing some connectors. But also, as I showed, we have some LDS antennas or fully custom FPC, PCB antennas that we can integrate in your application. And as also part of our service, we do pre-certification testing so that you can be sure when you go to the test house that you will pass the certification. I mentioned we have two different FPC Wi-Fi antennas, one with a little bit higher gain and one with a little bit lower gain. If you want to be sure that you will pass the certification, you will pick the lower gain version. But if you want really maximum performance, I advise to test out the higher gain version, and we measure it in our chamber to see if it's really reaching the maximum gains required for the certification. And then you have the absolute maximum performance that you can reach in the application, and you are sure that you will pass the certification. I just have some customer who has to pay a couple of 10,000 euros additionally extra because he failed the first certification, and just to retest the antenna, he needs to pay a couple of €1,000 again, a second time. And of course, also using some manpower, using some work and finding a new antenna, testing it, maybe having some field tests. So that's just a nice service that we can offer additionally to our layout review, to our simulations and other measurements that we can offer. So that's it also from my side. Thanks a lot for your time and your patience. I think if you have any questions, you can always reach out. You can use the chat now, and Kirsten, you will summarize everything.
Okay, many thanks to you, Jens, and also Albertano for your interesting presentations. We also received some questions already. So the first question is for you, Albertano. Where can we find the end-of-life plans for Intel Wi-Fi modules?
So we have two documents which highlight the end-of-life plan. I will share shortly with you.
So maybe general information, whenever you have an Intel NDA, you have access to our developer zone. If you don't have that, please reach out to Rutronik, and they can provide you all that information with the correct document number, and you can find that easily online.
Yeah, more specifically, the end-of-life find for CCG can be found in this Intel RDC document that you can see here. You can see here in this slide on the bottom. And for the next product, we also have a quick reference guide indicating the launch date and all the related information for the next modules.
Mm-hmm.
Okay.
Many thanks. The next question is regarding antennas. What are the main factors to consider installing PCB FPC antennas in MIMO setup?
That's a good question. So usually what we recommend is to have an orthogonal layout. So you have one antenna orthogonal to the PCB, or in best case, both antennas orthogonal to the PCB, but also orthogonal to each other. So And in this way, you can cover the most polarization ways. So you have a vertical and horizontal polarization that you can cover, but also you have the spatial coverage to have the best setup for catching all the magnetic waves or sending all the magnetic waves in each direction. And very similar for the stubby antennas, if you just have one antenna up and one antenna vertical to that, in this way you usually get the best performance and the best coverage overall.
Okay, thank you. And next question. How to grant customers access to Intel OEM tools, for example, DRTU tool?
And this is what Frank already said, right?
Mm-hmm.
So the customer should have an NDA in place with Intel.
Mm-hmm.
And then as soon as the NDA is in place, we can enable access to the DRT tool.
Okay, thank you. What is the most important parameter for the certification of the antenna side?
Yeah, that's a very tricky part, as I think also Albertano covered. It's very important to be within the regulations and the requirements, of course. So it's always necessary to check the data sheets of the antenna and the modules together. Intel has a very, very nice overview what are the requirements to certify the parts, and we also looked it up in advance for this meeting. And the two main important parameters are the type of antenna. So for each type of antenna, if it's an external antenna or an FPC antenna or chip antenna or whatever, it has different requirements on the technical parameters. And the technical parameters are usually gain, which is the most important, because that's the value that defines how strong the signal will be in the end. But also, as I said, the measured gain is not always according to the datasheet, because in the datasheets we always have a specific setup that we tested, and we cannot test every single setup there is in the world in each application. So it's really important to measure the antenna performance in each individual setup.
Okay, thank you. What are the current lead times for antennas and also the Intel modules?
I can just start with that. So usually we have around 9 weeks, so it's quite fast. We also have a lot of parts in stock, a lot of parts at Rutronik in the stocking packages, but we also have our own sample ordering tool. If you have any questions for that, you can just reach out to Rutronik or to me, and we can double check if we have samples. But regularly it's around 9 weeks, and the lead times are still very, very stable. We still advise to order as fast as possible, just so we can plan the production ahead.
Okay, thank you, Jens. And for the Intel modules?
Sorry, I was on mute. Yeah, for the Wi-Fi modules, basically we have no lead time. We have inventory, and our distribution partners usually as well. Of course, there can be always here and there one specific SKU, which has maybe a lead time, but in general, we are absolutely supply healthy.
Thank you, Frank. And the last question I see for the moment is, on which platforms Intel Wi-Fi modules have been validated?
So this information can be found in our message of the month. I can show you 1 second. So this is the document message of the month. And in the message of the month, you can find is an exhaustive document where you can find everything that you need for Wi-Fi modules design in. And in here, you can also find, here, you can see the table for each Wi-Fi module, where the module has been validated with which operating system. And this is including the Wi-Fi 5, the Wi-Fi 6E modules, and also the latest Wi-Fi 7 Okay, so you have the status of the validation for each Wi-Fi module family.
You get to this document when you have an Intel NDA and access to our developer zone.
Okay, thank you. So I don't see any further questions at the moment. Of course, if you have any questions later on, don't hesitate, please contact us. We are happy to help you. Many thanks again to Jens, Frank, and Albertano for your presentations and all the information you provided. For your information, we will have further webinars in our Rutronik Connect series. So tomorrow there will be a next webinar with our supplier Silex Technology, and on Friday with Nordic Semiconductor. And the next webinar series of Rutronik Connects regarding cellular technology will start in October. So if you haven't registered yet, we would be happy to see you in these webinars as well. Check out our website. All the information is there already. Okay, so thanks again. Thanks for participating in this webinar and have a good day.
Thank
Thanks
you.
again from my side.
Thank you. Bye.
All right.
Bye-bye.